Hello, my voice is audible.
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay, ma. Today we will discuss that is a replacement models. It is a unit number 70. Directly, replacement. When we will do that is a replacement. For example, your certain expiry date after that will be replacement is needed. That replacement when we should do the perfectly. That is, for example, is a marriage bulbs. Marriage bulbs we will arrange that is a bulbs. Certain time period after 1 or 2 months that bulbs will be failed. That total bunch they will be removed and a new bunch will be added. Similar manner in our home also needs of the goods. Here, for example, here after completing that we will purchase that is a new goods. That is a daily warehouse of materials. That is a totally completed. That is a completed task is different. When that it is a repairable or a modifications are required. For example, you have a fridge. What happened? It is a for after the 2 years or 3 years or 4 years after that again we should go for the maintenance. After 20 years also do you go for the maintenance? No, because of we actually that is already totally it is a destroyed. So before that only, before 4 years or 5 years, after using of the 6 years, 7 years, immediately that is we will be resale. We will put the resale and we will purchase that is a new item. That is one kind of the model. Another kind of the things are we have a car or bike. Here after using that is a 1 year or 2 years or 3 years or 5 years, we should replace the tires. The tires is a immediately after completing 1 year immediately do you replace? No, that is you will go for that is a maintenance. After 3 years we will go for the maintenance. 4 years we will go for the maintenance. 5th year it is the tire is damaged. At the time we should be replaces. Otherwise it is will not helpful to the
Sir, excuse me, sir.
Sir,
Yes,
chapter
replacement models unit is
మాకు బుక్ లో లేదు సార్ ఇచ్చిన మెటీరియల్ లో.
chapter లేదు సార్.
counting
లేదా?
principles and designating functions ఉంది సార్.
సార్ 17th chapter వేరే ఉంది ఇందులో.
1 second అమ్మా.
ఫస్ట్ ఇయర్ సార్. yes.
Grammar and language
ఉంది సార్.
Unit 17 sir, sorry.
This is unit 17th.
Yes
No
sir.
sir, 16th only. Grammars and languages correct only sir.
16th sir.
Counting principles of the generating function.
Yeah, unit 17th. Yes sir.
Yes, sir.
Okay. Next, we will go further one more, 18th, last unit.
Recurrence relation, sir.
Yes, is it correct?
Recurrence relations.
Is it there?
Yes.
Yes, sir.
It's the 18th chapter.
Okay. Okay, now we will start. That is the 18th. It is easily we can score this one. Yeah, recurrence relations means it is repetitions. How many times we can get the repetitions? So that is called as a recurrence relations repetitions. After studying this unit, you will be able to the different kind of a recurrence relations and what is the quote of the certain examples we can discuss in this aim and objective of this unit. Secondly, it is a different kind of the classifications of the recurrence relations. Any types of my any types of discuss also. Explain the meaning of the solution of the recurrence relation. Recurrence relation solutions should be identified. Solve the homogeneous recurrence relations by standard methods like iterative methods నుండి follow చేయొచ్చు. అంటే ఇందులో కూడా homogeneous and non-homogeneous two types of recurrence relations are there. అందులో కూడా standard methods we can apply for that is the homogeneous recurrence relation point of view finding the solutions. So it is a iteration method is one method, another method is the characteristic roots method and a method of generating functions. So this is important. Next, after that is a non-homogeneous recurrence relations are there. Obtained it's a complete solution as a sum of the solutions of the associated homogeneous relations, like it is a n power h and particular integral. It means the complementary and particular integral, how we can be identified. Same way, where homogeneous relations of n power h and a particular integral of the non-homogeneous relations we can be identified. In both, it is a homogeneous recurrence relations only. So what is the recurrence relations means? It is based on the repetitions, based on the redundancy. It is a continuation process. It is a simulations. It means that is a combinations. All we should be checked. All permutations we can be checked. And partitions, how many partitions we can classify that partitions also we can make it. These all the combinations we can be discussed. This is a kind of the unit is called as a recurrence relations. This recurrence relations is a reduces the problem involving the n number of objects and n number of objects to one involving n minus one number of objects. Then one involving n minus two number of objects. It means that mathematical induction, what it says that is a one is the true. What we will go, n equal to k is the true. Then after that is a n equal to k plus one also true. Then it is a total statement is also true. Similar procedure we can be adapt and I can implement for that. It is a n is a true, n minus one also true, and n minus two also true. Like that, it is all one is also true. So it is a coming to the 1, 2, 3, so on up to n condition, continuously successive approximations. That is comes to the it is a solving of iterations. This is a overall idea about that is a recurrence relations. Now here method of it is a recurrence relations. One example if I take, what is it? It is the first sequence is a 1, 5, 9, 13, so on. First number is how much? 1. What about the next number? N square plus 1. Then here 1 and 3 having the one kind of the relationships, and another 5 and 13 is another kind of the relationship. So here and third is the recurrence relation is fn minus 1, and next relationship we have that is fn minus 2 relation. Both combined is called as a fn relation. So like here, sometimes recurrent relations, example, if I take an equal to an minus 1 plus 4, this is also one kind of the good relationship. So anyway, it is a sum of that is a fn equal to fn minus 1 plus fn minus 2, or f1 equal to f2 equal to 1. This kind of observations is comes to the recurrence relations. Recurrence relations definition is a recurrence relation is one of the formula related to the nth term observation of the sequence, that s equal to bracket of sn. Bracket of sn. Bracket of sn, we have it terms at the a1, a2, so on up to an minus 1 term. So all the terms we will write in a set of the form. That set of the form is called as a total group of the bunch is called as a, that set is a S, that capital S is a sequence. So that's writing of the nth term is called as a recurrence relation. Recurrence relation. Example is I'm taking an plus 1 equal to 3an. So this is comes to the n is greater than or equal to 0 is the recurrence relation. So 1 I know, A1 I know. So 3 times of A1 equal to A2. A3 if I want, 3A2. A4 I want, 3A3. So it is a third if you know that I can identify the fourth one. Fourth if I know that I can identify the fifth one. Here fourth if I know I can identify fifth. The fifth is I know I can identify the sixth. Sixth I know that I can identify the seventh. Seventh I know I can identify the eighth. This kind of the observations are called as the recurrence relations. The based on the before term we can expect there is a next term. Continuously up to nth term we can be expected. Here the another example I can take the Fibonacci series. Fibonacci series is a one term, one will be there. Here previously one will be added to the one. 1 plus 0 equal to how much? 1. Previous term are 0. So 1 is a 1 comma 1. Again, both continuously next to two terms I will add. 1 plus 1 equal to how much? 2. Next previous term is 1 and in coming term is a 2. Both if added I can get the 3. Then 3 I will add it to the previous term, it is a 2. So it is a term is a 5. 5 and previous term is a 3. Both if you added I can get the 8. This is a continuation is close to the, this is called as a Fibonacci series. The Fibonacci series is a clearly satisfy the recurrence relation Fn equal to Fn minus 1 plus Fn minus 2. So some of the previous terms and next term is close to the nth term. That is comes to the Fibonacci series. F1 equal to 1 and F2 equal to 1. Example of the another term, if I take, example of the another term, if I take, R term I want to be observed. So that I take that is the an equal to an minus 1 plus R into an minus 1. So that is equal to the 1 plus an minus 1. In particular, a0 equal to p and a1 equal to 1 plus r into p, a2 equal to 1 plus r into a1 equal to 1 plus r whole square into now it is a a0 equal to p and a1 equal to 1 plus r into p and a2 equal to 1 plus r into a1 equal to 1 plus r whole square into p. So that it is a an equal to 1 plus r whole to the power n into p gives that is a recurrence relation. Example, if I take that is another terms, it is a D arrangements or permutations of 1, 2, 3, so on n, in which the none of the n integers appear into the their natural places positions. So I1, I2, so on. In is a D arrangement of the I1 is not equal to 1, I2 is not equal to 2, In is not equal to n. The number of D arrangements of 1, 2, 3 can be the partition into the two classes. Consider an arbitrary D arrangement into the 1 into the ith position or 1 is not into the ith position. In former cases, the remaining terms of n minus 2 number of D arrangement of these terms and I1 can be chosen to the n minus ways. So that it is a, we can be right into the n minus 1 into D, n minus 2 is a D arrangement of the kind. So it is a, we know that is a previous one, we can identify that is the next number. So it is a continuation of the process. D arrangement system, it follows that is a Dn equal to n minus 1 of Dn minus 1 plus n minus 1 of Dn minus 2. So sum of the Dn minus 1 term and Dn minus 2 term, it is total is equal to the Dn. This is a best observation of the D arrangement of the recurrence relation. Here many recurrence relations, examples I can take here. These all are the an equal to r into an minus 1 is one of the recurrence relation. Another recurrence relation is a an minus 3 an minus 2 plus 2 times of an minus 2 equal to 0. And if I take that as a third term cases, an minus 3 an minus 1 plus 3 an minus 2 equal to n square plus 4. And an equal to an minus 3 times of an minus 1 whole square plus 2 times of an minus 2 equal to 5an. An equal to a0 into an minus 1 plus a1 into an minus 2 plus 1 an minus 1 into a0. An square plus an minus 1 whole square equal to minus 4. Hello? Sir, please. Yes, sir. No, అవును సార్ ఇంట్రెస్ట్. ఓకే సార్. Let n comma k be
Sir,
the
can we
non-negative
write
integer.
only one definition?
Once again.
No, can we write only one definition? Classification
Yes.
of recurrence reactions. So
Yes,
first is
it is
important, sir, or second is important?
Here recurrence relations, it is a depends on the degree we can decide that is a which one we can write it. So first you listen the both. That is called as
Okay,
the
sir.
classifications of the recurrence relations.
Okay, sir. Thank you.
It is a both definitions means it is a both different kind of. One is a linear kind of, it is a non-linear kind of the systems will be there.
Okay, sir.
So here above all are the examples of the recurrence relations. Recurrence relations means it is a nth term and n minus 1, n minus 2. It is a, I want a 0, n equal to 2 if I take. It is a a0, I can, first term. 2 means a1 is a, and a 3. And it is a relation between that is a a1, a2, and a3. So that it is a 3 terms of the observations. So based on that, it is a continuation of the a4, a5, a6, a7 up to an the term observations I can take. This is the relationship is called as a recurrence relation. Though above all are the some 6 or 6 examples will be the same kind. It is a starting term. It is up to, it is extended to nth term. That nth term is a nth terms n minus 1, and before what kind of the how many terms relationships we have, that is a continuation procedures relationships of the nth term we can be get it. That is called as a recurrence relations of examples. Classifications, it is a definition point of view. N comma k be the non-negative integers. If I take the n comma k are the non-negative integers, the recurrence relations of the form C naught of n an plus C1 of n an minus 1 plus so on C k of n an minus k equal to f of n. Here all are the C naught, C1, Ck and f of n are the functions of n, not a constant. Functions of n is said to be a linear recurrence relation. All are the functions if I take, it is called as a linear recurrence relation. Now coming to the second definition, here C0 and Cn are not identically 0. These two terms are the not zeros. Then the above linear recurrence relation is said to be a degree is the k. Degree is the k. So that it is a C0, C1, so on, Ck are the constants. Then the relation is called as a linear recurrence relation with constant coefficients. In the definitions, if we ask that is a linear recurrence relation with constant coefficients, we can go for that is a second definition. That is 18.3.8. Linear recurrence relation with constant coefficients. It is the linear recurrence relations. If we ask, we can use that is only 18.3.7. These all are the not the constants and even so on. Cn are the functions. Cn are the functions. If the functions, it is a linear recurrence relation, and it is with the constant coefficients. It is a linear recurrence relation with the constant coefficients. You should be mentioned clearly. This is a differences between that is the classifications of the recurrence relations in the linear. It is a functional, another is coming to the constant coefficients. Examples, if I take that, it is an example of that. It is a 18.3.9. The recurrence relation 2 are the constant coefficients recurrence relations I am taking. What is the an coefficient is 1 and an minus 1 coefficient is minus 3. An minus 2 coefficient is 2. So it is a degree is equal to how much 2. And the relationship is clearly an equal to an minus 3, an minus 1, 3 an minus 2 equal to n square plus 4 is of order 2. So this is also, both are the examples of the recurrence relations. Now coming to the 18.3.10. Here, this is also another definition for the non-homogeneous or homogeneous kind. F of n equal to 0. The recurrence relation is said to be a homogeneous. It means that in that examples, it is a right side terms are the 0. See here, example 2, right side is 0. 18.3.6, so it is right side is 0. It is called as a homogeneous recurrence relation. Right sides are the constants. It is called as a non-homogeneous recurrence relations. So Fn of 0 equal to Fn of f of n equal to 0, right side term of the recurrence relation is clearly homogeneous recurrence relation. Otherwise, it is non-homogeneous recurrence relation. All are the remaining 1, 2, and the other terms are the right side is a term is exists. Therefore, it is called as non-recurrence relations. I think up to here, everybody understood. Is it clear? Do you have any doubt? Hello, ma.
Yes, sir. No doubt.
Okay, fine. Solution of the recurrence relation. Solution of the recurrence relation. Already you know that x square minus 5x plus 6 equal to 0. Now, this is x square minus 5x plus 6 equal to 0. Solving of this, what are the roots we can get? But this is clearly quadratic equation. So I can get the roots are the minus 3 come minus 2 on.
3, 2. Minus 3, yes, sir.
Minus 3 and minus 2 are the roots.
Sir,
Similarly, I can apply for these recurrence relations also. I will consider in the roots formation, and it's that power is I will take n. Root is a 5 if I take 5 power n is called as a solution of the recurrence relation. So similarly, above equation example, I am taking the recurrence relation of an minus 5 an minus 1 equal to 0. I am asking to solve this equation. I am asking to solve this equation. What happens? It is clearly I can take it is a an is a x square. An minus 1 is how much? It is x only. So x square minus 5x equal to 0. So x equal to 0 and x equal to how much? 5. So it is getting that is an equal to how much? 5 to the power of n. Before term, if I take an minus 1 is clearly 5 to the power of n minus 1. So it is a solution of this recurrence relation is clear. I can get that an equal to got it 5 to the power of n. So that 5 power n minus here 5 into here 5 power n minus 1 equal to 0. So that anyhow it is a 5 power n is clearly satisfied this equation. Therefore, 5 power n is called as a solution of the recurrence relation with the constant coefficients. So finally, judgment is we can give that the an equal to any constant c into 5 to the power of n is called as a solution of the recurrence relation. Solution of the recurrence relation. Now, if I take that as example, an square plus an minus 1 whole square equal to minus 4. It is does not comes under the category of the solving of that is a equation. So relation is not having that is a solution. At the time we can go for that is a formal definition of the solution of the recurrence relation type we should be apply and then we can solve it. Whenever easy manner we have that at the minus 1 equal to 0. Such equations is easily we can identify that it is a solution x minus 5 equal to 0 so that it is x equal to 5. So 5 power n is a solution so that n equal to c into 5 power n is the recurrence relation solution. Now, such kind of above squaring form of the equations we can solve by using that is the below procedures. Now, it is example 18.3.13 if I observe. Now solve that is the recurrence relation of that is an minus 7, an minus 1 plus 8, an minus 2 equal to 0, where n is greater than or equal to 0. This is a solving of this. What I can take that it is x square minus 7x plus 10 equal to 0. Here, what I am taking an is the x square. So an minus 1 is the x, an minus 2 is a constant 1. So that it is a x power 0. An minus 2 is a x power 0. So here I can get that is the equation is x square minus 7x plus 10 equal to 0. What are the roots I can get that it is a 5 to 10 so that it is a 2 comma 5 are the solutions. Roots. So that
sir, minus 5 minus 2, no, sir.
Once check. It is a an minus 7 an. Sorry, it is a x square minus 7x plus 10. 5 to 10. So I can get that is a minus 5 into a minus 2 equal to 0. A minus 5 into a minus 2 equal to 0. So a minus 2 equal to 0 means a equal to 2. A minus 5 equal to 0, a equal to 5. So plus only. So an equal to C1 into 2 power n plus C2 into 5 power n is called as a required solution of this recurrence relation. Sometimes we will ask that is whether it is a solution is correct or not. Verify. What I do, that is the same thing I will substitute here. What I got it is a n equal to C1 2 power n plus C2 to 5 power n. I will substitute in the place of an. An minus 1 means it is a C1 into 2 power n minus 1 plus C2 into 5 power n minus 1. N minus 2 term means 2 power n minus 2 plus 5 to the power of n minus 2 term. Now, after multiplication and simplification, automatically it will get that is a 0. Therefore, that is a what you have taken, that is a n C1 2 power n plus C2 2 power 5 power n is called as a solution of the recurrence relation. For the given an minus 7, an minus 1 plus 10, an minus 2 equal to 0. This is called as a solution of the recurrence relation, how we can be identified. Sometimes you will ask that is what are the C1 and C2? Already you are taking that is a an equal to C1 2 power n plus C2 power 5 power n. So C1, C2 also identification point of view. He will give that is some condition. A not equal to 10. It means that is a you substitute that is a n equal to 0. N equal to 0 in a an equal to C1 2 power n plus C2 5 power n. So here n equal to 0 means a not equal to C1 2 power 0. 2 power 0 is 1 plus C2 into 5 power 0. Only C2. So C1 plus C2 equal to a naught. So a naught he gave in the condition is a 10. 10 equal to C1 plus C2. Second condition is a a1. So n equal to 1. You write that is a a1 equal to C1 into 2 power 1 plus C2 into 5 power 1. I can get that is a 2 C1 plus 5 C2 equal to a1. a1 equal to 41. So solving of these two equations, I can get that is a a1 and a2. Sorry, C1 and C2. C1 equal to 3 and C2 equal to 7. So therefore, the general solution, this is called as a general solution, is a n equal to, sorry, particular value. So I am giving so that it is a particular solution. So the particular solution or prescribed solution is clearly Cn an equal to 3 into 2 power n plus 7 into 5 power n is a solution of the recurrence relation. Now coming to that, it is in terms of an minus 1 comma an minus 2 so on a1 a naught. Thereby computing the an plus 1 in terms of an comma an minus 1 so on an a naught and so on the provided the value of the sequence at 1 or more points is given to you the initial to the computing. This is called as a recurrence relations, how we can identify the solution. Up to here, solution identification. Everybody understood or not? Do you have any doubt? You can raise. All are understood? All are understood?
Sir.
Hello, do you have any doubt?
Doubt, sir.
Up to here.
Sir, roots అనేవి ఎలా ఫైండ్ అవుట్ చేయాలి సార్?
an equal to x square, an minus 1 equal to x, an minus 2 equal to x power 3.
an is equal to x square, a minus 1 is equal to 7x
Yes.
plus 10
Plus
equal to 0.
X power 0. X power 0 is 1. So 10 into 1.
సార్ ఈసారి సొల్యూషన్ ఎలా వచ్చిందో చెప్పారా? 10 41 not even values.
మళ్ళీ చెప్పరా?
సార్ ఏ నాట్ ఈక్వల్ టు 10, a1 ఈక్వల్ టు 41 ఎలా వచ్చాయి ఒక్కసారి చెప్పాలా సార్ ప్లీజ్?
నో ఏ నాట్ వాడే ఇస్తాడు కండిషన్స్. ఏ నాట్ ఏ1 వాడు ఇస్తాడు. ఇచ్చినప్పుడు మాత్రం అది పర్టికులర్ సొల్యూషన్ మనం ఫైండ్ అవుట్ చేస్తాం. వచ్చిన సొల్యూషన్ an ఈక్వల్ టు C1 2 power n plus C2 5 power n లోపల వాడు పర్టికులర్ వాల్యూస్ ఇచ్చినప్పుడు సబ్స్టిట్యూట్ చేయాలి. an ఈక్వల్ టు ఇచ్చాడు మనకు an ఈక్వల్ టు సొల్యూషన్ కదా, n ఈక్వల్ టు 0 రాస్తే a నాట్ వస్తుంది. అంటే a నాట్ వాడు ఇచ్చాడు కాబట్టి 10 సబ్స్టిట్యూట్ చేసుకోవచ్చు అని అర్థం. a1 ఈక్వల్ టు 41 వాడు ఇచ్చాడు కాబట్టి n బదులు 1 రాస్తున్నా. నా సొల్యూషన్ an ఈక్వల్ టు C1 2 power n plus 5 C2 5 power n లో n ఈక్వల్ టు 1 రాసుకుంటే n a1 బదులు నేను 41 సబ్స్టిట్యూట్ చేసుకోవచ్చు. అప్పుడు 2 C1 plus 5 C2 అవుతుంది. అర్థమైందా అమ్మ? అర్థమైందా? హలో
ఓకే సార్.
అమ్మ మీకు సొల్యూషన్ వాళ్ళకు సొల్యూషన్ వచ్చిందా? సొల్యూషన్ ఫైండ్ అవుట్ చేయడం వచ్చిందా? అక్కడ ఏదైనా డౌట్ ఉందా? వెరిఫికేషన్ అన్నప్పుడు సొల్యూషన్ సొల్యూషన్ వస్తే
సార్
ఎట్లా
ఇక్కడ
చేయాలని
మనము
అడిగినా
వాల్యూస్ ఇప్పుడు రూట్స్ దగ్గర మనం -5 -2 అంటున్నాం కదా సార్, ఇక్కడ కాబట్టి ప్లస్ అని తీసుకున్నాం కదా. సో అది ప్రతిసారి ప్లస్ ఉంటుందా సార్?
అంటే మీకు డౌట్ ఎక్కడ వచ్చింది
సార్? ఇక్కడ మీరు ఎగ్జాంపుల్ చెప్పారు చూడు సార్, an - 7 an - 1 + 10 an - 2 = 0. సో ఇక్కడ జనరల్ మనం ఏమనుకున్నాం, x² - 7x + 10 = 0 అనుకున్నాం. సో దీంట్లో ఇప్పుడు -5 - 2 వస్తుంది మనకి.
అవును,
కానీ ఇక్కడ ఈక్వేషన్ లో
-2 -5 రాదమ్మా. ఒకసారి నేను ఇక్కడ చేస్తాను, మీరు చూడండి.
ఓకే సార్.
మీరు నాకు ఈక్వేషన్ చెప్పాల్సి ఉంటుంది. ఒక్క నిమిషం, కోడ్ ఓపెన్ అవుతుంది.
అంటే సార్ x - 5 = 0 అన్నప్పుడు x = 5 అవుతుంది. అది అనుకొని 5 తీసుకుంటున్నాం.
అవును,
కానీ ఇది వరకు మరి ఫస్ట్ దాంట్లో సార్ సొల్యూషన్ ఆఫ్ ద రికరెన్స్ రిలేషన్స్ అక్కడ చెప్పినప్పుడు x² - 5x + 6 అన్నప్పుడు -3 - 2 అని రాసాం సార్. అక్కడ మళ్ళీ ఎందుకలా? అక్కడ అప్పుడు -3 - 2 అన్నప్పుడు అక్కడ 3 2 అవుతుంది కదా సార్. అక్కడ కొంచెం డౌట్ ఉంది సార్.
అదే మీరు ఈక్వేషన్ చెప్తారు, నేను చెప్తాను. ఒక్క నిమిషం, స్టక్ అయినా. ఓపెన్ అయింది.
నా డౌట్ ఏంటంటే సార్, బిఫోర్ ఎగ్జాంపుల్ లో x² - 5x
మీరు చెప్పండి, ఈక్వేషన్ చెప్పండి.
x² - 5x + 6.
సో ఇది ఎంత రాయొచ్చు? 3 2 రాయొచ్చు.
-3
సో 5x - 3x 2x -3x - 2x + 6 = 0. x if I take the common x - 3 -2 if I take the common x - 3 = 0. రెండిటి x - 3 x - 3 into x - 2. సో x = 3 x = 2. సో ఇప్పుడు నాకు రెండు రూట్లు వచ్చేస్తాయి కాబట్టి an = c1 × 3n + c2 × 2n. ఇదే నాకు కావాల్సిన సొల్యూషన్.
ఇదే సార్. ఇక్కడ ఏమంటున్నానంటే సార్, దీనికన్నా బిఫోర్ దాంట్లో మనం వాల్యూస్ ఏమనుకున్నామంటే -3 - 2 వాల్యూస్ అంటున్నాం. ఈ వాల్యూస్ ఏమైనా తీసుకోవాలా అంటే నేను x = 3 వాల్యూస్ తీసుకోవాలా సార్, లేకపోతే x - 3 అన్నాం కదా, -3 అని తీసుకోవాలని డౌట్.
లేదు, ఇక్కడ మీరు అక్కడ మీకు అది ప్లస్ ఉంటుంది. ఇక్కడ +5x ఉంది. అక్కడ
-5x
x² + 5x + 6 x² + 5x + 6 ఉంది. అప్పుడు ఏం రాయొచ్చు? 3x 3 2 కదా. x² + 3x + 2x + 6
-3 - 2 అవుతుంది.
x × x + 3 x + 3 వస్తుంది. ఇది ఉండమ్మా.
అవును సార్.
x × x + 3
+ 2 × x + 3.
సో x + 3 × x + 2 = 0.
అవును.
అప్పుడు x ఏమవుతుందమ్మా?
-3 + 2 అవుతుంది.
-2.
ఇప్పుడు ఈక్వేషన్ ఎట్లా రాస్తాం
an
సార్?
-3 c1 × -3n + c2 × -2n.
ఇదే డౌట్. yes సార్. -3 ×
అర్థమైందా
సార్? కొంచెం డిస్టర్బెన్స్ వస్తుంది సార్, స్క్రీన్ సరిగ్గా అనిపించండి. -3
ఒక్క నిమిషం. నార్మల్ బోర్డ్. ఇప్పుడు చూడండి అమ్మా, మీరు ఏదో అడిగారు.
ఈక్వేషన్ సార్, ఇప్పుడు -3 -2 ఉన్నప్పుడు ఈక్వేషన్ ఎట్లా రాస్తాము? +3 +2 ఉన్నప్పుడు
-3 -2 ఉన్నప్పుడు 3 2 ఉన్నప్పుడు ఇట్లా ఏం లేదండి, సింపుల్ అంతే. an ఈక్వల్ టు దీనికేమో c1 -3 హోల్ పవర్ n ప్లస్ c2 -2 హోల్ పవర్ n. దీనికి ఏంది c1 3 పవర్ n ప్లస్ c2 2 పవర్. సైన్ తీసుకోవాలి ఇన్సైడ్, అంతకని చేయని అక్కర్లేదు. ఓకేనా?
yes sir.
కండిషన్స్ ఇస్తే ఇక్కడ కండిషన్స్ వాడతాం. వాడు A0 ఇచ్చినాడు 10 ఇచ్చాడు అనుకోండి, అప్పుడు పైన A0 రాస్తాను. A0 ఈక్వల్ టు ఎంత? c1 -3 హోల్ పవర్ 1 ప్లస్ -2 హోల్ పవర్ 0. ఓకే సార్, n కదా 0, -2 హోల్ పవర్ 0, సంథింగ్ పవర్ 0 is 1. కాబట్టి c1 ప్లస్ c2 ఈక్వల్ టు A0 వాల్యూ. A0 వాల్యూ వాడు ఏం ఇస్తే అది. నెక్స్ట్ A1 ఇచ్చినప్పుడు కొంచెం జాగ్రత్త చూసుకోవాలి. c1 ఇంటూ -3 హోల్ పవర్ 1 ప్లస్ c2 ఇంటూ -2 హోల్ పవర్ 1. సో -3 c1 -2 c2 ఈక్వల్ టు A1. A1 ఈక్వల్ టు వాడు ఏదో 41 ఇచ్చాడు అనుకో. అప్పుడు ఈ రెండు ఈక్వేషన్ సాల్వ్ చేసేసి c1 c2 ఫైండ్ అవుట్ చేయాలి. అక్కడ ప్లస్ ఉన్నప్పుడు ప్లస్, నాకు సంబంధం లేదు. ఓన్లీ -3 తీసుకున్నప్పుడు పవర్ లో ఏది ఉంటే అది సింప్లిఫికేషన్. చూడండి ఇక్కడ అదే సింప్లిఫికేషన్ చేస్తాం. అర్థమవుతుందండి?
yes sir.
Okay, sir.
Okay. Next, I'm going for the next continuation.
Okay sir.
Share. Screen అనిపిస్తుందండి? మా స్క్రీన్ కనిపిస్తుందా?
సార్
స్క్రీన్ 1 సెకండ్.
yes sir. ఇప్పుడు కనిపిస్తుంది.
కనిపిస్తుందా?
yes sir.
Okay, fine. Next, similarly we can use that is a different problems he gave, that it is the bottom of the question. This iterative procedures. Iterative procedure means it is a backtracking method. We called as a backtracking method. Backtracking method means it is a solve the recurrence relation an equal to an minus 1 plus n into here an equal to an minus 1 plus n and then iteration procedure ఖచ్చితంగా a1 equal to
సార్ వాయిస్ బ్రేక్ అవుతుంది సార్.
బ్రేక్ అవుతుంది.
వాయిస్ బ్రేక్ అవుతుంది. ఒక్క నిమిషం, నాకు ఏం చేయాలి? నెట్ హలో అండి, వాయిస్ క్లియర్ ఉందా? హలో.
yes sir.
yes sir.
ఓకే, స్క్రీన్ కనిపిస్తుందండి?
yes sir.
yes sir.
ఓకే, సాల్వ్ ద రికరెన్స్ రిలేషన్ ఆఫ్ an ఈక్వల్ టు an minus 1 ప్లస్ n అనేటువంటిది వాడు ఇచ్చినటువంటి ఈక్వేషన్ అండి. వాడు ఇటరేషన్ ప్రొసీజర్ లో ఫస్ట్ ఖచ్చితంగా a1 అనేటువంటి a0 అనేటువంటిది ఖచ్చితంగా ఇస్తాడండి. అప్పుడు నేను ఫస్ట్ తీసుకోవాల్సిన సొల్యూషన్ ఎలా ఫైండ్ అవుట్ చేయాలంటే an ఈక్వల్ టు an minus 1 ప్లస్ n అని ఇస్తాడు. సో నెక్స్ట్ రికరెన్స్ రిలేషన్ ఏమవుతుందండి, ఇదే దాన్ని n minus 1 లో రాయండి, n బదులు n minus 1 రాయండి. అప్పుడు an minus 2 ప్లస్ n minus 1 ప్లస్ n. అదే దానికి మళ్ళీ n minus 3 లో రాయండి, an minus 3 ప్లస్ n minus 2, అంటే n బదులు n minus 2 రాస్తుంది, ప్లస్ ఆల్రెడీ n minus 1 ఉంది, ప్లస్ n minus 1 ప్లస్ n యాస్టీస్ రాస్తాను. నెక్స్ట్ అప్ టు లాస్ట్ వరకు వెళ్తే a1 ప్లస్ 2 ప్లస్ 3 ప్లస్ సో ఆన్ అప్ టు n అవుతుందండి. అప్ టు ఇది ఏమవుతుందండి సిరీస్ ఫామ్ 1 ప్లస్ 2 ప్లస్ 3 ప్లస్ ఆన్ n సమ్ ఆఫ్ n టర్మ్స్ కాబట్టి ఫార్ములా n ఇంటూ n ప్లస్ 1/2 ఇదే మనకు కావాల్సిన సొల్యూషన్ అవుతుంది. హలో
సార్
అర్థమవుతుందా ఇక్కడ?
అర్థమైంది సార్.
నెక్స్ట్ క్వశ్చన్ ఈ విధంగా ఇస్తాడు, సాల్వ్ ద రికరెన్స్ రిలేషన్ అని అడుగుతాడు. an ఈక్వల్ టు an మైనస్ 1 ప్లస్ f ఆఫ్ n. యూ కెన్ రైట్ దట్ ఇస్ a1 ఈక్వల్ టు a నాట్ ప్లస్ అంటే 1 n బదులు 1 రాస్తారు, n బదులు 1 రాస్తే 1 మైనస్ 1 0 a నాట్ ప్లస్ f ఆఫ్ 1. సో a2 ఈక్వల్ టు a1 ప్లస్ f ఆఫ్ 2. f of 2 instead of a1 above a naught plus f of 1 I will write. So a naught plus f of 1 plus f of 2. Next a2 equal to what I can write, a2 plus f of 3 no from the given equation. So a2 is a upper value, it is a2 will be there, that a2 I will substitute here, that I will get that is a naught plus f of 1 plus f of 2 plus so on f of n. Up to it is coming to the last term an equal to what I can get finally a naught plus f of 1 plus f of 2 plus so on f of n. So this we can write as a naught plus summation k equal to 1 to n f of k. This is called as a recurrence relation of the iteration. Recurrence relation of iteration. Solution, what is the solution? A n equal to a naught plus summation k equal to 1 to n f of k is called as the solution itself. Solution అంటే ఇది అంతకు మించి వేరే రాయడానికి ఉండదు. అమ్మ అర్థమైందా ఇది? మోస్ట్ ఇంపార్టెంట్.
ఓకే సార్.
18.4. Okay, right. Now I am going for that is 18.4.3. So it is a constant, same method we can be applied. Now it is examples. Sometimes we will give that is geometric series formations. Geometric series formations means it is a bottom an equal to 2 power n plus a naught plus 2 power n minus 1 when we have a powers. At the time an equal to 2 power n minus 1 plus so on plus 2 square plus 2 plus 1. So an equal to, it is called as a 1 minus a to the power of n by 1 minus a, so that it is a 2 power n minus 1. So this is kind of the equations. Whichever is that we will apply the same procedure. It is a previously it is a sum of n terms I used. Here it is a sum of instead of sum of n terms it is having the geometric series, so that r equal to 2, so that directly 1 minus r to the power of n by 1 minus r. Like that I can use this one. Some series is 18.4.5. an equal to 2 into an minus an by 2 plus n minus 1 for n is greater than or equal to 2. The equation belongs to the class of the recurrence relation is called as a divide and conquer rule I will apply. What is the meaning of the divide and conquer? First we should make that is a division, then after that a combined. Division, divide means it is a divide, you do that as an equation into the divide form. Then after that conquer means add it. So for example I am taking that is the repetitions of this term. It is a example a equal to 2a n by 2 plus n minus 1 term. So I am taking that is a an equal to 2 a n by 2 plus n minus 1 is the first equation, given equation. I don't know that is a 2 times of a n by 2. So that 2 times of a n by 2 I will write in terms of another second term. What happens is the 2 times of a n by 2 I can write it 2a n by 4 plus n by 2 minus 1. Now we can go for the product. What happens? It is a 2 square into a n by 2 plus n minus 2. Again I can go for that is a 2 square into a n by 4. Similarly, it is coming to the up to last term, a n minus 2, a n minus equal to n minus 1. If I added all the terms, I can get that is a n equal to n minus 1 plus n minus 2 plus n minus 2 square plus so on n minus 2 power k minus 1. Here, 1, 2, 3, so on up to k n terms will be there, so that it is a kn. Rest of the terms is the minus 1 plus 2 plus 1 plus 2 power k minus 1 will be there. What I can write it is kn equal to, sorry, kn minus 2 power k minus 1 is called as nth term. So that kn minus, it is a 2 power k minus 1 is called as n minus 1. This is clearly appears like a n into log n base 2 plus n minus 1. Because of k equal to how much it is log n base 2 we can take. This is called as a recurrence relation for the iterative procedure by using that is a divide and conquer. Divide and conquer means it is a given term. We can write into the divided form, and again we should be add it all the terms. That is called as the recurrence of the total. I can get the recurrence of the total is a an equal to n minus 1 plus n minus 2 plus n minus 2 power 2 plus 1 plus n minus 2 power k minus 1. All the terms, if I take that is the sum of the terms, it is a k m terms will be there. So n will be the k, so that km minus 1 plus 2 plus 1 plus 2 power k minus 1 is a n minus 1, so that it is a n log n base 2 plus k minus n minus 1. It is a k equal to log n base 2. This is the overall idea for that iteration and backtracking method. Backtracking is comes to the by using the by backtracking means it is a this procedure is called as a backtracking. Example 18.4.5. I'm tracking with the all of the addition of the terms, so that it is comes to the backtracking. Next, iteration means just A1 is a, you should write that is a sum of the series formations. Then it is a sum of the series formations. We can write into the solution form. These are the two ways for the iterative methods and backtracking method. Do you have any doubt in this? Iteration and backtracking. Iteration and backtracking. Do you have any doubt?
No, sir.
No. Okay, fine. Now I will go for that is the next is a method of characteristic roots.
కేకి క్వశ్చన్స్ రెండు ఉన్నాయి కదా, రెండు మెథడ్స్ ఒకటే కదా?
రెండు మెథడ్స్ ఒకటే.
ఇటరేటివ్ బ్యాక్ ట్రాకింగ్ రెండు ఒకటే మెథడ్స్. అంటే 2 ways లో అడుగుతారు ఇలాగా, అంతేనా?
2 ways లో అడుగుతాడు. 2 ways లో అడిగినప్పుడు ఇటరేషన్ ను వాడాలి, బ్యాక్ ట్రాకింగ్ మెథడ్ లో బ్యాక్ ట్రాకింగ్ వాడాలి, ఇటరేషన్ వాడాలి. అల్లమ్మా, అందుకనే బ్యాక్ ట్రాకింగ్ ఏం కనబడుతుంది అంటే ఇటరేషన్ లాగానే కనబడుతుంది. ఎగ్జాంపుల్ ఒకసారి చూస్తే కిందది లాస్ట్ ప్రాబ్లం ఏం చేస్తున్నాను చూడండి, డివైడ్ చేస్తూ వస్తున్నాను. అన్ని డివైడ్ చేసినటువంటివన్నీ సమ్ చేస్తే అప్పుడు నీకు ఒక రిలేషన్షిప్ ఎగ్జిస్ట్ అవుతుంది. అంటే ఏంటిది, నువ్వు బ్యాక్ ఎండ్స్ అన్ని యాడ్ చేసావు అని అర్థం. దట్ ఈస్ కాల్డ్ as బ్యాక్ ట్రాకింగ్. ఇటరేషన్ అంటే ఏంటి, నువ్వు ఏ దాని చోట ఎక్కడైతే అవసరం ఉందో అక్కడే సబ్స్టిట్యూట్ చేసుకుంటూ పోతున్నావు. ఇదో ఇక్కడే దానికి నెక్స్ట్ టర్మ్, దానికి నెక్స్ట్ టర్మ్, అంటే చిన్న చిన్న ప్రాబ్లంకి ఇటరేషన్ వాడేస్తాం. కొంచెం పెద్దగా అనిపించింది అనుకోండి ప్రాబ్లమ్స్ కు మనము బ్యాక్ ట్రాకింగ్ ప్లస్ ఇటరేషన్ వాడాలి. ఇంకమ్మా ఇంకేదైనా డౌటా? Right. Next, method of characteristic roots. C0 an plus C1 an minus 1 plus so on plus ck an minus k equal to f of n. N greater than or equal to k. This method is we can apply for that. It is a non-homogeneous recurrence relation with the k constant coefficients. First, you should the non-homogeneous, you make it to the homogeneous. Because of it is f of n equal to 0, you take the homogeneous. Homogeneous, if we make that and find out the roots, then after that we can go for that is a solution is a an into dr power n, dr power n. So in that also equations we can get that is a c0 into r square plus c1 into r plus c2 equal to 0. Same in the mundu lagane first procedure lagane. Right side 0 అయితే it is a homogeneous కాబట్టి ఇంత ముందు చేసిన procedure as it is apply చేయాలి. It means that is the left side term is the same. Left side terms is the roots are the real and distance. ఇంతవరకు రూట్స్ ఆర్ రియల్ అండ్ డిస్టెన్స్ గురించి మాట్లాడాను. ఒకవేళ రూట్స్ ఆర్ రియల్ అండ్ ఈక్వల్ అండ్ కాంప్లెక్స్ అయితే ఏంటి ప్రొసీజర్స్ అనేది చదవాల్సి ఉంటుంది. సో రూట్స్ ఆర్ ద రియల్ అండ్ డిస్టింక్ట్ ఉన్నప్పుడు నేను రాసిన ప్రొసీజర్ ఏంటి, an ఈక్వల్ టు c1 r పవర్ n ప్లస్ c2 r టు ది పవర్ ఆఫ్ n. ఇదే జనరల్ సొల్యూషన్ అని చెప్పేస్తాను. సంతోషం. దానికి డైరెక్ట్ గా అక్కడ ఎగ్జాంపుల్, ఇక్కడ ఒక ఎగ్జాంపుల్ తీసుకుంటున్నాను. దీనికి రూట్స్ a0 ఈక్వల్ టు -1, a1 ఈక్వల్ టు 8 వచ్చేసింది కాబట్టి డైరెక్ట్ గా రూట్స్ సొల్యూషన్స్ రాసిస్తే ఏమొస్తుంది, c1 -1 హోల్ టు ది పవర్ ఆఫ్ n ప్లస్ c2 8 టు ది పవర్ ఆఫ్ n. సారీ, ఇక్కడ a1 a2 కండిషన్స్ అవి. సో an ప్లస్ an -1 -6 an -2 ఈక్వల్ టు 0. దీనికి రూట్స్ ఏమొస్తున్నాయి అబ్బా, 2 కావు -3, 2 కావు -3 కాబట్టి an ఈక్వల్ టు c1 2 పవర్ n ప్లస్ c2 -3 పవర్ n. ఇందులో n ఈక్వల్ టు 0 రాసేస్తే అప్పుడు a0 వస్తుంది. నెక్స్ట్ n ఈక్వల్ టు 1 రాస్తే a1 వస్తుంది. సాల్వ్ చేస్తే కాన్స్టెంట్స్ C1 C2 ఫైండ్ అవుట్ చేస్తారు. దట్ ఈస్ కాల్డ్ యాజ్ ఏ లెఫ్ట్ సైడ్ టర్మ్. అంటే రైట్ సైడ్ హోమోజీనియస్ అంటే రైట్ సైడ్. ఇదంతా హోమోజీనియస్ గురించి మాట్లాడేస్తాం, ఇటరేషన్, బ్యాక్ ట్రాకింగ్. నెక్స్ట్ ఇట్ ఈస్ కమింగ్ టు ద రికరెన్స్ రిలేషన్స్ వచ్చినప్పుడు Fn+2 ఈక్వల్ టు Fn+1 ప్లస్ Fn. ఇటువంటి టైమ్స్ లో కూడా నాకు ఏంటిది రూట్స్ వస్తాయి, కాంప్లెక్స్ రావచ్చు, ఇర్రేషనల్ రావచ్చు. ఇప్పుడు నాకు ఇక్కడ ఏం కనబడుతున్నాయి, ఇర్రేషనల్ కనబడుతున్నాయి. Fn+2 అంటే ఎంతమ్మా, R². Fn+1 అంటే R, ఇటువైపు రైట్ సైడ్ వెళ్తే -R. Fn రైట్ సైడ్ ఉంది, అది లెఫ్ట్ వెళ్తే ఏమవుతుంది, -1. సో R² -R -1 ఈక్వల్ టు 0. R ఏమవుతుందమ్మా, -B + R - B² - 4AC/2A. సో R ఈక్వల్ టు -1 1 + R √5/2. So Fn equal to, we can write the solution C1 into 1 + √5/2 whole power n. Same అంతే, ఏమొస్తాయి రాస్తాం అంతా, 1 - √5/2 whole power n. ఆల్రెడీ కండిషన్స్ ఇచ్చాడు. ఏం కండిషన్ ఇచ్చాడు, 0 ఒకటి ఇచ్చాడు, 1 ఇచ్చాడు. చూడు Fn equal to 0 and F1 equal to 1 అని. So F0, if I substitute C1 plus C2 relation, C1 equal to -C2. C1 equal to -C2, if I substitute F1 equal to C1, అది కూడా 1 substitute చేస్తే both are solved. I can get that is 1/√5 is a C1 and -1/√5 is a C2. So Fn equal to 1/√5 into 1 + √5/2 whole power n minus 1 - √5/2 whole power n. So this is important number. 18.5.5. Then after that example, we can go for that. It is a computer science applications. We can be use these are ivanni kuda available. Next thing kavalama, solve the recurrence relation. It is the same procedure. Em ostunnai, ఇది cubic equation చూడండి. Cubic equation అంటే ఎంతమ్మా, an అంటే x⁴0, an+1 x, an+2 x², an+3 x³ అంటే 2x³ - x² - 2x - 1 equal to 0. అంటే ఇప్పుడు సాల్వ్ చేస్తే ఏమొస్తుంది, రూట్స్ 1, -1, 1/2. Therefore 1 power n -1 power n and 1/2 whole to the power of n form 3 linearly independent solutions. Therefore general solution an equal to C1 plus C2 into -1 whole to the power of n plus C3 into 1/2 whole to the power of n. So this is called as our required solution. ఏదైతే నేను 2 రూట్స్ క్యూబ్ రూటింగ్స్ వస్తాయి అంతే. ఫైండింగ్ ఆఫ్ ద C1 C2 C3 ఆల్రెడీ వాడు ఇచ్చేసాడు, C1 C2 C3 in the question itself. So no, A0 ఇచ్చాడు, A1 ఇచ్చాడు, A2 3 ఈక్వేషన్స్ ఇచ్చే సాల్వ్ చేస్తే సరిపోతుంది. C0 C1 3 ఈక్వేషన్స్ 3 అన్నోన్స్ కాబట్టి 3 ఈక్వేషన్స్ సాల్వ్ చేస్తే C0 C1 C1 C2 C3 సబ్స్టిట్యూట్ చేస్తే పోతుంది. దిస్ ఇస్ ఓవరాల్ అగైన్. Solve the recurrence relation of an equal to 4an - 1 plus 5an - 2. A1 equal to 2 and A2 equal to 6. Same procedure you can apply. If case it is the roots are the repeated. Yes, it is a roots are the repeated cases. Repeated cases means here we will take that as a solution A0 R power n plus A1 into n into R power n అండి. రిపీట్ అవుతే ముందు ఒకటి n రావాలి. So on up to am -1 n to the power of n -1 into R power n. అంటే రిపిటేషన్స్ వస్తున్నాయని చెప్పడం. This is called as a roots are real and equal. Roots are real and equal. చూడండి కింద ఈక్వేషన్ కి వచ్చేస్తాయి, రూట్స్ ఆర్ రియల్ అండ్ ఈక్వల్ వచ్చేస్తాయి. కాబట్టి సొల్యూషన్ డిజర్వ్డ్ సొల్యూషన్ ఏం రాస్తున్నా, an equal 2 power n plus 1/2 n into 2 power n. 2 power n plus 1/2 into n into 2 power n. Here I identify the C0 and C1. C1 C2 కూడా కనుక్కున్నాను కాబట్టి డైరెక్ట్ సబ్స్టిట్యూట్ చేయడం వల్ల C1 equal to 0, సారీ C1 equal to 1 and C2 equal to 1/2 కాబట్టి అవి సబ్స్టిట్యూట్ చేస్తాం. బట్ ఇట్ ఇస్ ద రూట్స్ ఆర్ రియల్ అండ్ ఈక్వల్ కాబట్టి n into 2 power n తీసుకోవాల్సి వస్తుంది. 2 power n plus 1/2 into n into 2 power n. This is a roots are real and equal formations. Allama amma ikkada varaku evarkaina doubts unnaya?
No sir.
No, sir. No, sir.
Okay. Anyhow, this problem 18.5.11, అందరూ ఒక పెన్ను పేపర్ తీసుకొని సాల్వ్ చేయండి. డూ ఇట్ ఫాస్ట్. I give the 5 minutes time. In 5 minutes, you should be complete. It's important. 5 minutes, you should be complete. 18.5.11. అమ్మా వచ్చిందా?
చేస్తున్నాం సార్.
ఓకే.
Good afternoon, sir.
అయిపోయిందమ్మా? Are you getting the same answer? Completed? Are you getting the same answer? Hello, ma.
Sir, good afternoon, sir.
Good afternoon. చెప్పండి అమ్మా.
సార్ నేను ఈ రోజే సార్ క్లాస్ జాయిన్ అయ్యాను. ఇది పీజీ ఫస్ట్ ఇయర్ క్లాస్ ఏనా సార్? మ్యాథ్స్.
అమ్మా ఇది మ్యాథమెటిక్స్ క్లాస్ ఫస్ట్ ఇయర్ పీజీ.
అంటే ఏ పేపర్ సార్? ఇది సెకండ్ పేపరా సార్?
మ్యాథమెటిక్స్ సబ్జెక్ట్.
సెకండ్ పేపర్ ఏనా సార్? రియల్ అనాలిసిస్.
ఇది రియల్ అనాలిసిస్ క్లాస్ కాదమ్మా, డిస్క్రీట్ మ్యాథమెటిక్స్ అమ్మా.
ఓకే సార్.
అమ్మా ఆన్సర్ వచ్చిందా? Do it fast. అమ్మా కంప్లీటెడా?
No, sir.
Completed. Here also roots are the equal. I will go for that in the next sheet. Parts. Complex roots.
Hello.
Hello, ma. అయిపోయిందమ్మా కంప్లీటెడా? అమ్మా కంప్లీటెడా?
No, sir.
सर ये C1 C2 तो इसमें दिया ना वो करेक्ट आ रहा सर उसको
C1 C2 also करना अम्मा.
आ रहा सर ये करेक्ट आ रहा 1.82 बराबर आ रहा.
ओके.
तो उसके बाद क्या करना सर इसको AN में इसका सब्स्टिट्यूट करना है किसके वैल्यू
C1 C2 सब्स्टिट्यूट कर. AN में C1 C2 सब्स्टिट्यूट करना.
हाँ ओके सर.
सबमिट करने तो हो जाता. आंसर वही भी आंसर है.
ओके सर. सर n की जगह क्या सब्स्टिट्यूट करना n की जगह 1 सब्स्टिट्यूट करे तो यहाँ पे 2.5 दे दिया ना सर A1
नहीं n लिखना.
AN में n डाले तो यहाँ सॉल्यूशन दे दिया ना सर इन्हें उन्हें आंसर दे दिया ना सर यहाँ
भी n में आता. सॉल्यूशन भी n में आता.
तो इसमें खाली वो फिट कर देने का होता है तो उसमें
n पावर में n आना.
सर यहाँ सॉल्यूशन दिया ना सर AN = C की जगह 1.82 डाल दिए फिर माइनस ब्रैकेट में फिर उसकी जगह -3 पावर n डाल दिए फिर यहाँ C2 की जगह 0.989 n ऐसा डाल दिए. ये सॉल्यूशन
बस दैट इज ओनली द सॉल्यूशन है ना.
हाँ वही
कोई भी प्रॉब्लम हो गया. नाउ हियर कांप्लेक्स रूट्स आने तो इधर कांप्लेक्स रूट्स వచ్చినప్పుడమ్మా here r1 r2 means it is a minus b plus or minus square root of b square minus 4ac by 2a find out చేస్తే इधर see here नीचे प्रॉब्लम दे जाइए an equal to 2 times of an minus 1 minus an minus 2 equation same we should write here r square minus 2r plus 2 equal to 0. Here 1 plus or minus I Here two roots we have. 1 plus I whole power n, 1 minus I whole power n. So solution क्या हुआ? Here an equal to c1 into 1 plus I whole power n plus c2 into 1 minus I whole power n. Either c1 c2 be arbitrary constants here. In condition देने तो a c1 c2 find out करना. नहीं तो इधर an equal to c1 1 plus I whole power n plus c2 1 minus I whole to the power of n ना ये भी the answer है हमको. ఇక్కడ answer ఇదే అవుతుందండి. So same answer here only. Here an equal to c1 1 plus I whole to the power of n plus c2 1 minus I whole to the power of n. This is only the answer. Because of complex roots will be there. Here instead of complex, so here real roots what we have same place I will write the complex. 1 plus I is different from 1 minus I. So that I am taking that is a one root is a 1 plus I. Another is a 1 minus I. So the power is I am taking n. Now here 1 plus I we should write in a form of that in a cos theta plus I sin theta. Here 1 plus I mod means it is a root of coefficients 1 square plus I coefficient is 1. So 1 square plus 1 square is a root 2. Cos theta it is y by x. It is 1 by 1 means cos. When we will get the tan theta equal to 1 by 1. So theta equal to pi by 4. So that it is a cos theta equal to cos of pi by 4 plus I sin pi by 4. So here if it is an under minus n to 1 minus I. Either लिखना here root into cos pi by 4 minus I sin pi by 4. So instead of writing 1 plus I, we can write as a root 2 cos pi by 4 I sin pi by 4. Here instead of writing 1 minus I, we can write minus root 2 cos of pi by 4 minus I sin pi by 4. So under power n, power n we can write inside. So cos n pi by 4 plus I sin n by 4. So here दो भी common में here root 2 whole power n. Okay, so बाहर लेने तो it means that it is we can take the common to the root 2 whole to the power of n. We will take the common. What are the term we can get? It is a c1 cos n pi plus I sin n pi and c2 cos n pi minus I sin n pi. So either k1 in terms of the cos n pi by 4 we can take the common. So that cos n pi by 4 we have in k1 into what is the k1? c1 plus c2 cos n pi by 4 plus k2 instead of k2 it is I into c1 minus c2 cos sin n pi by 4. Then after you substitute the initial condition. What is the k1 a naught? It is 1 a1. So find out after that we can get that is a k1 and k2. K1 k2 if you substitute that is called as our required answer. This is called as a complex roots. Complex roots if we get we can write if this is the procedure. Here do you have any doubt Amma? Procedure understood or not? An c1 r to the power of n plus c2 r1 to the power of n plus c2 r to the power of n. That's all. An equal to root 2 whole to power n cos n pi by 4 plus I sin n by 4. Next question. Solve the recurrence relation of an equal to b an minus 1 minus b square an minus 2. For n is greater than or equal to 3. A1 equal to b, a2 equal to 0. So an equal to d r to the power of n. So what happens here also same complex roots I can get. So that b into 1 by 2 plus I root 3 whole power n. So b into 1 by 2 minus I root 3 whole power n. Same procedure I can apply. I will get the A1 and B1. So that this is called as a complex roots. So here next method of general functions. Yeah, up to here 18.5 total is comes to the solution findings. It is a 3 cases: the real and distinct, and real and equal, and real and complex roots. Whose the solutions for the homogeneous functions we did. Homogeneous function. Next method of general functions, we can go for that. It is the right side also terms will be there. We can apply this as a procedure. This is also one kind of the generating function procedure. Generating function procedure here a and x power n we will substitute summation of. Summation of if I substitute summation of a of x is equal to a of x is the solution case. Here you will apply the summation case. So that generating the functions sometimes it satisfy the what is the recurrence relation. Generating function it satisfies the recurrence relation. At the time, that is a what satisfies that equation. That equation is called as a solution. What you are substituting genetic function. That genetic function only the solution. So genetic function, if we will in advance, we can take it. That is only the one of the idea. According to the equations, whenever he will give that is a sequence formations, C of k comma n, if we give, we use a generating function is a 1 plus x whole power k m. Wherever we have a minus 1 whole to the power of n and a power n, there we use that is a 1 by 1 minus ax. Then here, C k minus 1 plus n comma n will be there 1 by 1 minus x whole power k. N plus 1 will be there. I can use the 1 by 1 minus x whole square. N will be there, x by 1 minus x whole square. N plus 2 into n plus 1 will be there, 2 by 1 minus x whole power 3. N plus 1 into n, 2x by 1 minus x whole cube. N square will be there, x into 1 plus x by 1 minus x whole cube. N plus 3, n plus 2, n plus 1, 6 by 1 minus x whole power 4. N plus 2, n plus 1 into n, so that it is a 6x by 1 minus x whole power 4. N cube is there, x into 1 plus 4x plus x square by 1 minus x whole power 4. N plus 1 a power n will be there, 1 by m, 1 minus ax whole power whole square. N a power n equal to x by 1 minus ax whole square. So these all are the recurrence relations. When is the generating functions will come? Is a of x equal to summation n equal to 0 to infinite, a n into x power n. These all are the 1, 2, 3, 4, 5 up to k. These are called as generating functions. Now recurrence relation by using the generating functions we can apply. Example is like this. So first it is a an will be there. Apply the both sides summation an x power n. Next an minus 1 x power n, 7 I am taking comma. An minus 2 x power n, 10 I am taking the comma. So x power n equal to what is that? A of x minus a naught. Similarly here a of x minus a naught. The x, so that it is a common term. I can get that is a naught plus a1 plus a1x minus 7 a naught x. So that a of x equal to a naught plus a1 minus 7 a naught x by 1 minus 7x plus 10x square. Now it is a partial fraction, so we can separate it. C1 by 1 minus 2x plus C2 by 1 minus 5x. So C1 into summation n equal to 0 to infinite 2 power n into x power n plus C2 into summation n equal to 0 to infinite 5 power n into x power n. So directly we can apply that an equal to C1 2 power n plus C2 into 5 power n. Then conditions we can apply. Generating function means it is a we can apply what ax equal to summation an x power n. Then terms will be there. It is a nth term will be there. We can apply squaring. Depends on the term, so we can substitute that. Here ax first term is how much? A of x. Last from the starting back to we will come back. First is a of x. Second is a of x minus a naught. Third is a of x minus a naught minus a1x. Fourth is comes to the a of x minus a naught minus a1x minus a2x square. What are the terms are there? Next term will be there. A of x equal 1 minus what is the x cube terms or 2 terms? All a of x you take and one time. Then we go for the partial fractions. That it gives that is a solution of the series. This is a example. All of you practice this one automatically. You can easily understand that it is a what is a generating function procedure. Generating function procedure. Problems only important. Here 3 equations solving of that I can get that is a C1, C2, C3. Here also generating function.
समझाना ये बहुत मुश्किल दिख रहा।
कहाँ?
ये इक्वेशन है वो थोड़ा मुश्किल दिख रहा था। दूसरा चैप्टर समझा।
कहाँ? इक्वेशन बोलो कहाँ से? एग्जाम्पल बोलो। 18.6.4
हाँ 6.34 ये मुश्किल दिख रहा।
हाँ थोड़ा जिगजैग में आते थोड़ा पूरा सीक्वेंस में देख के अंडरस्टैंड होना आप। इधर देखो once again एक्सप्लेन करें हम। Here an minus 9a n minus 1 plus 26 a n minus 2 minus 24 a n minus 3 no। इधर कितना टर्म है इधर?
कौन सा सर 18.6.3 है पूरा?
24 a n minus 3 18.6.4 स्क्रीन नहीं दिख रहे?
हाँ दिख रहे
हाँ, कितना टर्म है इधर? an एक, an -1 दो, an -2 तीन, an -3 चार, चार टर्म्स है ना?
हाँ यस सर।
चार टर्म से आप a ऑफ x मल्टीप्लाई करना, समेशन a इनटू x पावर n,
ओके सर।
ठीक है ना?
हाँ दिखे सर दिखे।
नाउ हियर उधर आने तो हियर ax माइनस a नॉट, कहाँ an माइनस, हियर उधर an -2 में समेशन ऑफ x पावर n, इट इज a ऑफ x माइनस a नॉट सब मल्टीप्लाई करना, और नीचे आएंगे तो, और उधर आएंगे तो a ऑफ x माइनस a नॉट, अभी ये देखो इधर फर्स्ट टर्म में a ऑफ x है ना?
हाँ जी सर।
और उधर आने तो a ऑफ x माइनस a नॉट, और
हाँ
आने
यस।
तो a ऑफ x माइनस a नॉट माइनस a1x, इधर ऊपर 24 है, कुछ भी नहीं है, इधर से क्या हुआ x टू द पावर ऑफ 3 लिखे, थर्ड टर्म है ना?
हाँ यस सर यस।
उधर इधर 26 x स्क्वायर, बाजू में इधर a ऑफ x माइनस a नॉट प्रोडक्ट होता है आप इधर से। नाउ और इधर -9x टर्म प्रोडक्ट करने तो क्या होता है, इधर टर्म तो सेकंड टर्म है ना, सो a ऑफ x माइनस a नॉट माइनस a1 ऑफ x, और पीछे आने तो a ऑफ x माइनस a नॉट माइनस a1 ऑफ x माइनस a2 x स्क्वायर।
ओके सर।
नाउ अभी a ऑफ x कॉमन ले लो, बाद में क्या हुआ, वो कॉमन टर्म नीचे आते, कॉमन नहीं तो a ऑफ x टर्म नहीं तो राइट से ले लो, a ऑफ x टर्म है तो लेफ्ट साइड, सो a ऑफ x इक्वल टू इट इज अ राइट साइड टर्म, नीचे आने तो 1 - 9x डिनोमिनेटर में आते, और पार्शियल फ्रैक्शन होना पड़ता, पार्शियल फ्रैक्शंस में 1 c1 by 1 - 2x plus c2 by 1 - 3x plus c3 by 1 - 4x। इधर कैसा करना बोले तो इधर और हमारा सेलफोन नहीं, कैलकुलेटर में इधर 1 - 9x plus 26x square minus 24x क्यूब का क्यूबिक रूट्स आते इधर सिंप्लीफिकेशन करने तो, वो लिखने तो बस c1 by 1 - 2x plus c2 by 1 - 3x plus 1 c3 by 1 - 4x, ऊपर ना को छोड़ दो, बट नीचे क्या हुआ, वो नीचे कैलकुलेटर में करने तो आपको आते 1 - 2x into 1 - 3x into 1 - 4x, वो लेने तो बस, और आने के बाद a ऑफ x इक्वल टू c1 डायरेक्टली फार्मूला में इधर क्या हुआ 1 माइनस ऑफ ax बोले तो a पावर n, ये क्या हुआ 2 पावर n, और सेकंड टर्म में 3 है 3 पावर n, थर्ड टर्म में 4 है 4 पावर n,
4 पावर n 5 पावर n,
वही भी आंसर है। अभी समेशन पूरे कॉमन ले लो, और ये कैलकुलेशन ऑफ c1 c2 c3 के पास he give the value, so he will give क्या दिया, ये इधर a नॉट इक्वल टू 0, a1 इक्वल टू 1, a2 इक्वल टू 10 दे रही, वो सब्स्टिट्यूट करने तो इधर एक एक टर्म कंपेयर करना, इधर कंपेयर करने तो ये फर्स्ट टर्म क्या हुआ, an इक्वल टू c1 2 पावर n प्लस c2 3 पावर n, c4 4 पावर n कॉमन ले लो, बाद में a1 इक्वल टू a नॉट 0 सब्स्टिट्यूट, प्रीवियस कैसे करने वो भी करने तो आपको 3 इक्वेशन में 3 रूट्स आते, c1 इक्वल टू 3/2
c1 c2 c3 आ जाते हैं, वैल्यू आ जाती है,
तो c1 c2 c3 सब्स्टिट्यूट करने तो हो जाता है।
यस
ठीक है ना?
ओके थैंक यू।
ओके, और थोड़ा समय अदर एग्जांपल्स में डायरेक्ट देते हो ना, कुछ भी प्रॉब्लम है, डिनोमिनेटर क्या हो क्या वही भी ले लो बस, इधर देखो इधर क्या हुआ, वो 1 - 2x होल क्यूब आ रहे,
यहाँ पावर 1 है, यहाँ पावर 2, यहाँ पावर 3 आ रहा,
3 आ रहे, सो ये 1 - 2x होल क्यूब लिख सकते हैं, सो और इधर थर्ड टर्म ये लास्ट c3 के नीचे आते, और उधर आने तो c2 में पावर 2 आते, एंड और इट इज c1 में इट इज पावर 8 आते,
यस 1 2 3 ऐसा, और
वही भी इधर तो प्रोसीजर में सेम करना पड़ता। ओके
यस सर, फार्मूले को जरा देख लिए तो आ जाता सर,
हाँ, फार्मूले को थोड़ा देखना पड़ता, 2-3 टाइम्स प्रैक्टिस करने तो आता।
यस
Now either non-homogeneous बोले तो it is a right side term है तो non-homogeneous.
हाँ yes sir.
तो a1 equal to a0 plus f of
0 नहीं रहना होगा. 0 नहीं रहना.
हाँ 0 नहीं दे रहे.
हाँ okay.
Right side में 0 नहीं तो इधर non-homogeneous. Right side 0 is not there, it is non-homogeneous.
Yes.
ना right side इधर left side term कैसा करते हैं हमको मालूम है.
हाँ yes sir.
पूरा लेफ्ट साइड टर्म करने के बाद राइट साइड टर्म करना पड़ता है. राइट साइड टर्म कैसे करना, इट इज अ समेशन फार्मूला अप्लाई करें तो हो जाता. इधर दूसरा मेथड है, इट इज अ मेथड ऑफ अनडिटरमिन्ड कोएफिशिएंट्स मेथड है, हम यूज करने तो आ जाता है. ठीक है ना?
ओके.
18.7.2 एक पर देख लो, नया तो नेक्स्ट क्लास में देखेंगे. Is it clear? हो गया. This is a पूरा. This is only the concept of recurrence relations. Unit is over. Next it is summary and problems है and नीचे solutions भी एक पर देखो. and इधर में one long question आता है. एक short questions, एक long question.
ये चैप्टर में से?
हाँ ये चैप्टर में. ओके ठीक है ना?
ओके सर.
ओके नेक्स्ट क्लास टाइम हो गया और नेक्स्ट क्लास भी मिलेंगे दूसरा टॉपिक ले. We will take next topic into the new topic. Next new topic we will start on.
Okay sir.
Okay ma, we will wind up the session.
Okay sir. Thank you sir.
సార్ ఇప్పుడు నెక్స్ట్ క్లాస్ ఏముంటుంది సార్?
నెక్స్ట్ క్లాస్ రియల్ అనాలిసిస్ అనుకుంటాను.
రియల్ అనాలిసిస్ సార్?
అయిండొచ్చమ్మా. సార్ వస్తున్నారు మరి, నాకు అయితే ఐడియా లేదు. ఒకసారి మీరైతే రెడీగా ఉండండి. సార్ అయితే ఎవరో ఫ్యాకల్టీ అయితే వచ్చేస్తారు, నో డౌట్.
ఓకే సార్.
ఓకే అమ్మా, థ్యాంక్ యూ ఆల్. ఐఎమ్ వైండింగ్ అప్.
Thank you sir. Thank you.